Good morning, children. I hope you are all safe by staying home. Children, you already learned so many things in the earlier classes, that classification of matter like in the form of solids, liquids, gases and acids, bases, salts. Today we are going to learn another type of classification of matter, in which we are going to now see a slide. So, children, you can see the slide here, that is matter can be classified mainly into two types: pure substances, mixtures. Pure substances are again classified into elements and compounds. Elements are again classified into metals, non-metals, metalloids and noble gases. Children, today we are going to learn about metals and non-metals in detail, about their properties. Before that, children, let me show you a slide in which some pictures are there. You need to identify them as metals and non-metals. Okay, children. So, right. So, here copper is a metal, right. Gold is also a metal. Coal and sulfur are non-metals. Water, no, neither a metal nor a non-metal. Wood also neither a metal nor a non-metal. It is a, water is a compound and wood is a mixture. So, children, here let me show one slide in which you are going to see the periodic table. Children, here blue color elements are metals and green color elements are non-metals. Children, from this you can tell me most of the elements in the periodic table are, yes, metals. Metals are the most of the elements in the periodic table. So, before going to know about classification of these metals and non-metals, we have to clearly know about distinguishment of metals and non-metals. After this session, you will be able to distinguish between metals and non-metals, children, right, and also you are going to recognize the importance of metals and non-metals in daily life. Yes, children, right. For that, we need to discuss some properties of metals and non-metals. In that, first we are going to know about physical properties of metals and non-metals for the better distinguishment of metals and non-metals. Okay, children, let me tell you the physical properties of metals and non-metals. Sir. So, here children, here some physical properties of metals and non-metals are given in the chart. So, the first property of is sonority. Sonority is nothing but whenever a metal is, whenever we strike a hard surface with a metal, it gives a ringing sound like this. So, whenever we strike a hard surface with a metal, it gives a ringing sound which is called as a sonority. And what about non-metals? Non-metals won't give any sound. Non-metals won't give any ringing sound. The example is coal, it's dropped here. So, that is sonority property which metals have and non-metals does not have. Right. Okay, children. Next property is state. You are very well known, children. What is the state of metals? It is a solid state of metals. Yes. What about non-metals? You are inhaling oxygen during respiration, it is in gaseous state. And what about this, just now you have seen the sulfur on the slide, this is also in solid state or gaseous state, right. Okay, children. So, this is about the state of metals and non-metals. These are solid, these are solid or gas, right, children. This is about state. Now, next one is luster. What is meant by luster, children? Metallic shine is called as luster. You can see, children, the surface is brilliantly shining. So, this metallic shine is called as luster. Okay, children. What about non-metals? Is coal is shining? No, right, children. So, non-metals does not have the luster. Metals have the luster, non-metals do not have the luster. Okay, children. Next property is tensile strength. Tensile strength is nothing but the ability of a substance to bear a lot of stress and strain without breaking, right. That is, metals have lot of tensile strength. You know, most of the bridges they are bearing lot of weight on them, right? Railway bridges are there, right? Road bridges are there, in which iron is used a lot. So, metals have a lot of tensile strength. What about non-metals? You can see here, I can break the coal easily. So, tensile strength is very less for non-metals. So, non-metals do not have the tensile strength, it is very high. So, no, they do not have any tensile strength. Next property is malleability. Malleability is nothing but the property of a substance by which it can be beaten into thin sheets is called as malleability. For this, we can see one example, right? The property of a substance by which it can be hammered into thin sheets like this. This is called malleability, how thin a copper sheet is there. And you also know the very famous atomic model which is given by Rutherford, in which he used all for a scattering experiment, in which very thin gold foil he used in his experiment, right children? Okay. Next, what about non-metals? Can they be beaten into the thin sheets without breaking? No, it is not possible with non-metals. So, metals have malleability, non-metals do not have malleability, right children? So, what are the uses of this malleability? What are the uses of this sonority? Sonority is having the uses of the bells are used in homes and as well as in temples, right? So, in schools also. And what is the use of this tensile strength? So, for bridges already we discussed. What is the use of malleability? Used in packing food materials. For this we use aluminum food packing materials, right? So, like this. Next one is ductility. What is ductility children? Ductility is nothing but the matter, the property of the substance by which it can be drawn into thin wires. It is called as ductility. You can see here the aluminum wire. Aluminum wire is here. So, like this, by this what is the use of this ductility property by which they can be drawn into wires? So, children, by this transmission of electricity is taking place, right, from one place to another place. Not only this, several uses are there. So, what about non-metals? Can they be drawn into the wires? No, they cannot. Okay children. Next, conduction of heat and electricity. Okay children, for conduction of heat, you are very familiar with this. Your mother is cooking something in the kitchen in metallic vessels, is it right? So, they are conducting heat excellently. So, metals are good conductors of heat. What about non-metals? They do not conduct heat. So, next let us see conduction of electricity. Conduction of electricity by metals. You see children, here a small circuit, battery is the energy source, and a switch and connecting wires and a LED bulb. Now, I am connecting, there are some gaps are left to check the conductivity. So, now I am connecting the aluminum wire in this circuit. So, children, you can see bulb is glowing in this case. Okay children, right children, you can see the bulb is glowing in this case. So, aluminum is a good conductor of electricity, right children. Now, we have taken non-metal also here, that is sulfur. Sulfur is taken in the straw for our convenience, right, it is filled in the straw. Now, I am connecting in the circuit. Okay children, the switch is already on. Okay, so bulb is not glowing in the case of sulfur. So, non-metals are poor conductors of electricity. So, by this we can prove that metals are good conductors of heat and electricity, and non-metals are bad conductors of heat and electricity. Okay children. Next, boiling point and melting point. Just now we told the mother is cooking something in the metallic vessels. In the marriages they are using large temperatures for cooking the meals or something else, right. So, then the vessels are melting? No, because they have very high boiling point and very high melting point. What about non-metals? They melt easily, they have low melting points. Okay children, metals have high boiling point and high melting point, non-metals have very low boiling point and very low melting point. What about hardness? What about hardness children? Metals are very hard, they cannot be broken. What about non-metals? I am taking a coal, it is easily breaking, right children. So, hardness, about hardness, metals are rigid, non-metals are fragile in nature. What is mean by fragile, children? Fragile is nothing but the substance can be broken easily, it is called a fragile. Okay, children. Right. Next, last one property is density. Already you know, children, metals have high density, non-metals have low density. So, like this. So, like this we can discuss about various physical properties of metals, and I will show you one slide to see the importance of physical properties, children. Right. You can see here some aluminum food packing materials are there, and wire cables, and a bell, and for heat conduction vessels in the kitchen, right. Like this, these are the uses of physical properties of metals, and already we told these non-metals physical properties also finished. Now, let us see there are some exceptional cases, that is, which are contradiction to the statements which I have just now given, right, children. Let us see what are the exceptional properties in the next slide. Exceptional properties of metals. Okay, children. So, what we said, metals are in solid state. So, you can see, children, here in the thermometer, mercury is in liquid state. Mercury is in liquid state. You are obviously come across this situation. So, mercury is the only metal which is in liquid state at room temperature, and there are some other metals, cesium and gallium, they melt if you hold them in your palm, and lithium, sodium, potassium are the metals which they can be cut with the knife easily. They are very soft. Actually, what we said, they are rigid, and so we said density also high for the metals, but these alkali metals, lithium, sodium, potassium, they float on water. So, like this, children, we can discuss about the exceptional properties of metals. Let us see now exceptional properties of non-metals. Okay, children, what we said, the physical state of non-metals. Physical state of non-metals is either solid or gas, but there is some exceptional case. There is one non-metal which exists in liquid state at room temperature, that is bromine. And what we said, these are fragile in nature, but the diamond is the allotrope of carbon, which is the hardest natural substance ever known. And what we said, bad conductors of heat and electricity for the non-metals, but there is another allotrope of carbon, that is graphite, which is an excellent allotrope of carbon, that is excellent conductor of heat and electricity. This is the graphite lead which you use obviously in pencils, children, right. This is about physical properties of metals and non-metals, and exceptional properties in the metals and non-metals. Okay, children. Now, let us go to the session. By this, we are having some contradictions in the physical properties, we are unable to come to a conclusion by the physical properties. So, we need to depend on some other thing, that is the chemical behavior, chemical properties of metals and non-metals. Okay, children. Let us see chemical properties of metals and non-metals. Children, first let us see the chemical properties of metals. Okay, children, first let us discuss about reaction of metals with oxygen. Reaction with children, reaction with oxygen. Children, there are various metals, potassium, sodium, magnesium, aluminum, zinc, lead, iron, and copper. So, these metals react violently with oxygen. So, they are kept immersed in kerosene oil. To avoid this explosive reaction with oxygen, they are kept immersed in kerosene oil. And these metals at ordinary temperatures, we are discussing about, at ordinary temperatures they form a oxide layer which prevents further corrosion. Oxide layer. And what about iron? Iron does not burn at ordinary temperature, but iron filings burn excellently. What about copper? When it is hot, it forms a black copper oxide layer, right. That is about the reaction of metals with oxygen, but we need to know the nature of metallic oxides. For this we need to discuss small activity that is related to magnesium. When it is burnt in oxygen, what happens? Let us see the children slide. So, when magnesium burnt in oxygen, what happens, children? It burns with a white dazzling flame excellently. The white ashes we collect, and these white ashes are mixed with water, then we get a solution. We test it with a red litmus paper, which changes into blue. So, what is, children, you know already? If red litmus changes into blue, the nature of magnesium oxide is basic, right. So, that is what we have given here. Metal oxides are basic in nature. Another simple example, children, which you can do it at home, right, that is rusting of iron. So, when iron reacts with water in the presence of oxygen, it forms rust. So, what is the formula of rust, children? Fe2O3X H2O, right, children. So, this is the formula of rust. So, whenever this rust is collected and is mixed in water, we prepare a solution. We test this solution with the red litmus paper, again it turns into blue. Simply you can say that metal oxides are basic in nature. So, what we are going to conclude, children, here, metal oxides are basic in nature. Right. Okay, children. Next, let us see another chemical property of metals. So, in a reaction with oxygen, metals form the respective oxide. Okay, children. Next, children, reaction of metals with water. Children, you can see a slide in which sodium metal, a small piece of sodium metal is dropped in the water. It is giving excellent flame, that is, it is reacting very violently, explosively. So, reaction of sodium with water. So, generally whenever metal reacts with water, they form metal oxide and hydrogen gas is released. Right. When these again, which metal oxides which are soluble in water, they again in turn form metal hydroxide. Metal hydroxide. So, we have one example here, children, that is when sodium reacts with water, it forms sodium hydroxide plus hydrogen gas is released. So, to balance it, so 2Na, 2NaOH and 2H2O. Okay, children, this is the balanced equation. So, here sodium reacting very violently with water, just now we have seen, and children can see potassium and sodium, these and calcium, these react with cold water, they can react with cold water. And next, children, magnesium reacts with hot water. Next, children, aluminum, zinc, iron, they react with steam. And children, lead, copper, silver and gold, they not at all react with water at whatever the temperature, right. In this way, different metals react with water at different temperatures. By this, children, and one more thing, these up to from potassium to magnesium, they react with water and they form respective hydroxides, but aluminum, zinc, iron, they form the respective oxides. So, which are soluble in water, they are called as alkalis. Okay, children, right. Next, these are they cannot react with water at all. So, this is about reaction of metals with water. Okay, children. in these reactions children, as we go from left to right in these metals, the vigorousness will be decreased in the reactions. Next children, let us see reaction with acids. Okay children. So, you can see children here some arrangement, right, a retard stand is there and a test tube is there, to which one single hole rubber cork is there, through which a delivery tube is passed into the soap solution, and in the test tube before closing it with a single hole rubber cork, we added some zinc granules and dilute sulfuric acid to it. By this reaction some gas is released. Let us see what is the gas is released. So, in this way children, whenever metal reacts with acid, it gives salt and hydrogen gas. So, how to test the gas is hydrogen? So, just bring a burning candle near it, it will put off with a pop sound. Okay children, do all metals react with the same rate with all metals, with all acids? No, some metals do not react with acids. So, copper do not react with acid, copper plus acid, no reaction. This is because children, copper is less reactive than hydrogen, copper is less reactive than hydrogen. Okay children, the last chemical property of metals, we will see last chemical property of metals, that is reactivity of metals. Children, in this you can see a slide. So, just what we have taken, one test tube in which we have taken copper sulphate solution which is in blue color, we have taken 2 iron nails and one we kept aside, one we dipped into the copper sulphate solution and left undisturbed for some time. After some time we observed that the iron nail which is in the copper sulphate solution, it is converted into reddish brown color, and what happened to this copper sulphate solution? It lost its blue color, that is blue color is faded, it became into greenish color. So, let us see the reaction. So, in this way copper is deposited on iron. So, what happened here? Iron is displacing copper because iron is more reactive than copper. What happens children if we have taken the conversion? So, if we take copper plus iron sulphate, there will be no reaction. So, like this children, we can say that why there is no reaction, because iron is more reactive than copper. So, copper cannot displace iron from it. So, okay children, by these all reactions we can come to conclusion that the reactivity order of metals. So, how the reactivity order of metals is there with other substances. So, there is a potassium, sodium, calcium, magnesium, aluminum. Next, zinc, iron, lead, copper. Next, mercury, silver, platinum and gold. So, this is the highly reactive metals. Highly reactive metals. These are moderately reactive. These are least reactive. So, these highly reactive, moderate reactive metals are called inferior metals, and these metals are called superior metals because they do not react with others, right. So, in this way from the chemical properties of metals we can conclude this activity series. This is called as activity series. Activity series. So, by this we can conclude the activity series. Next, let us see chemical properties of non-metals. Children, chemical properties of non-metals. Children, non-metals do not react with water, and non-metals do not react with acids, just they react with oxygen. Reaction of non-metals with oxygen. So, for this we have one slide, children, you can see. So, sulfur is a non-metal, just now you have seen. So, sulfur is taken a deflagrating spoon and we start heating it, then sulfur dioxide gas is formed, formation begins, and immediately we kept it in the lidded glass jar to do not allow the gas to escape, and next we slowly add by taking care water to this lidded jar to do not allow the gas outside. So, this solution we again collect and we again test it with blue litmus paper. Now, the blue litmus changes into red. So, what is the nature of non-metallic oxides, children? So, you can say that if blue litmus changes into red, that is the nature of the non-metallic oxides is acidic. So, what is the commonly formed, children, here? Sulfur plus oxygen gives rise to sulfur dioxide. So, non-metals also form the respective oxides. So, what is the difference between metal oxides and non-metal oxides? Metal oxides are basic in nature, non-metal oxides are acidic in nature. So, like this, children, we can see the physical and chemical properties of metals and non-metals. So, we can distinguish between them. Now, let us see the uses of metals and non-metals. Uses of metals. Okay, children. So, uses of metals, you can see a slide. Children, they are used to pack food materials, they are used to make currency coins, medals, statues, and they are used to make agricultural instruments and aircrafts, spacecrafts, and lot of devices, electronic devices also made up of iron. And next, let us see uses of non-metals, children. Okay, children, for this also we have one slide. So, sulfur is used in ointments, and phosphorus is used in making matchsticks, and nitrogen is used in electric bulbs, children. Iodine is used in iodized salt, and not only in this, and iodine is also used in this tincture iodine, right, which is iodine in alcohol, and also chlorine is used in chlorination process, which disinfects the water, right. Like this, children, we can discuss several uses of metals and non-metals. Children, now take the project work. So, children, questions are: find out the reasons for the following. Aluminium is a highly reactive metal, yet it is used to make utensils for cooking. Sour substances like lemon or tamarind juice are effective in cleaning the tarnished copper vessels. Copper is used to make hot water tanks and not steel, an alloy of iron. So, okay, children. Now, so children, with this we complete our session. Like this, we can distinguish between metals and non-metals. Now, finally, I wish to thank Honorable Secretary Sir R.S. Praveen Kumar Garu and my regional coordinator Florence Rani Madam, and district coordinator Devasena Madam, and my principal, and the members, TSAT members and GnaanaDeeksha members, and all the staff who encouraged me, supported me for this. I thank you all. Thank you one and all.